Now with question number 4, we are given an information here about a piece of nickel foil, 3 different dimensions of the nickel, and then it says that you react that nickel with fluorine gas to give a solid product, which is a nickel fluoride compound. It tells you the density of the nickel, and then it's saying that if you make 1.261 gram of the nickel fluoride, what's going to be the empirical formula of the nickel fluoride. So the idea is that this is a combination of different concepts that you have to process through. One is, of course, there's a reaction between the nickel and fluorine gas. So one of the things you need to remember is fluorine is F2, right? And it forms some kind of a nickel fluoride. We don't know what the nickel fluoride is. We're going to put NiFX here. And you might say, well, why not NiXFY? And the reason we don't have to worry about that is because remember that fluorine is -1 in terms of its charge. So if the nickel is +1, F would be 1, and then nickel +2, F would be 2, etc. So that's why the formula is just this. So the goal is just to find out that X. The information we're given is the dimensions of the nickel. That allows you to calculate the volume of the nickel. You're also given the density of the nickel. So volume and density leads you to mass. The mass can then be converted to number of moles of the nickel. Nickel and nickel fluoride has to have the same stoichiometric coefficient, with the F here being a half times whatever the number happens to be, right? So for example, if X is 3, then this would be 3 halves F2, giving us that balance equation. The coefficient of F here has to be X over 2 or 1/2 X to make this equation a balance equation. But what's important is that the coefficient of the nickel itself has to be the same as the coefficient of the nickel fluoride. And that's what's going to help us, because if we know the number of moles of the nickel, that means that because the nickel fluoride and nickel have the same coefficients, the number of moles of the nickel fluoride would be the same. Okay? So now, if you know the number of moles of the nickel fluoride, and you were given that there's this much mass of the nickel fluoride, then you can calculate the molar mass of the nickel fluoride, and that's just going to be mass over its number of moles. And once you have the molar mass, you can subtract out the nickel to find out how many fluorine you have, and then find out how many X. So the X then can be calculated by taking the molar mass of the compound, which you're going to find in the previous step. You're going to subtract out the molar mass of nickel. Once you do that, you just be left with the molar mass of all the fluorine atoms. And you're going to divide that number by the molar mass of the fluorine to find out how many fluorines you have. Okay? So that's kind of the steps that we're going to do. First, I'm just going to calculate the volume. It's just going to be equal to 1.25 centimeter, right, times 1.25 centimeter times the thickness, which is 0.55 meters. So we just convert it to centimeters, so it'd be 0.055 centimeter. If I work this out in my calculator, I should get a number that's equal to that, 0.059 cubic centimeter. Once I get my volume, I'm going to use density and volume to get mass, and that's just, mass is just density times volume. So density is this number. Volume we just got was this number. And you should get 0.7655 grams. That's your mass. And remember that the mass would then be converted to number of moles. That's step 2 right here, right? So to get number of moles from mass, we're going to have to take the mass that we just got, 0.7655 grams, and then divide that by the molar mass of nickel, which we can find in the periodic table here is 59. This is kind of a simplified molar mass here without any further significant digits. So if you get that, you find that there is 0.012975 moles of nickel, because the balance equation has to have a 1-to-1 relationship between the nickel fluoride compound and the nickel. So then this is, if you want to kind of work it out, you'll say the number of moles of the nickel fluoride, NiFX, would be 0.012975 nickel. And then basically you say it's 1-to-1. And so you end up getting the same exact number, 0.012975 mole nickel fluoride. Once we have the number of moles, we have the mass. Remember, that was given to us earlier. So now that allows us to calculate molar mass of the nickel fluoride. So molar mass of the nickel fluoride is going to be mass over number of moles, right? So 1.261 grams over the number of moles that we calculated earlier, which is 0.012975 moles. And that gives us a molar mass of 97.1861 if I calculated grams per mole. So that's my nickel fluoride, and remember the last step here, we're going to then use that to figure out how many fluorines we have. So to get our X, we would say that we take our 97.1861 minus the molar mass of the nickel. Remember, that's just 59. So now you're left with just fluorine once you subtract out the nickel, and then you're going to take that and then divide that by the molar mass of fluorine. Fluorine is 19. So this is all in grams per mole. Cancel, cancel. And you find that you're going to have 2 fluorine. Okay? So then the formula, therefore, is going to be NiF2. So we'll go back here. That's going to be our answer, is NiF2.